Hey guys, I wanted to walk through one of your practice problems from the number 2 conservation of momentum math practice. I think this is actually the second question. So it's number 2, and it's a classic momentum problem here. You've got a blob of putty moving, and it slammed into another blob of putty at rest. Right, a very real world situation here. So with all of these, we want to be able to calculate the speed of each blob of putty immediately after it collides, and then we want to calculate the change in momentum that each blob of putty experiences. Okay, so because we're dealing with momentum, a quick little reminder: the most important thing to recall about these types of problems is that the total momentum of the system before the collision is equal to the total momentum of the system after the collision, right? Because momentum is conserved, it can just kind of move around between different objects, right? So let's start off by identifying our blobs. I'm going to use some colors to keep it straight here. We'll call blob A this blue one here, and then we'll call blob B with the red. All right. Now, with all of these, I do recommend drawing a diagram, okay, and labeling that diagram with everything that we know. So we know that blob A is 2 kilograms, and it's traveling at 3 meters per second. It collides with ball B, which is also 2 kilograms, okay, but it's at rest, right? So its velocity is 0. Okay. Now, we're trying to figure out the total momentum of the system. So we have to identify what is the momentum of each blob before the collision and then add it together. Okay. Momentum of blob A, all right, recall our momentum equation, mass and velocity. Okay, so the mass times velocity, 2 times 3, that would give us a momentum of 6 kilogram meters per second. Okay, blob B is a little easier to calculate. I know it's at rest, so I know that its momentum has to be 0. Okay, it has to be 0 because it's not moving. So if we want to calculate the total momentum of this system, it's pretty easy. We're just going to add up our two independent momentums. Okay, so 6 plus 0, total momentum of the system is 6 kilogram meters per second. Okay. All right. So this is everything that's happening before the collision, and the only thing I know after the collision is that the two blobs stick together. Okay. So in my after diagram, boink, okay, I want to draw my two blobs stuck together. Now each blob still weighs 2 kilograms, but because they are stuck together, we can think of them as moving as one kind of system. Okay, so we could say that their combined mass, 2 plus 2, is 4 kilograms. Okay, we also know that the total momentum before the system, right, is the same as the total momentum after the system. So we'll just repeat total momentum down here, right, 6 kilogram meters per second. Okay, so that means that this whole thing is moving with a combined momentum of 6 kilogram meters per second, right? So if we want to figure out how fast it's going, we just got to recall our momentum equation. Okay, same one as before. Momentum is equal to the mass times the velocity. Well, the mass of this whole system is 4 kilograms. Okay, multiply by some velocity in order to get a momentum of 6 kilogram meters per second. Okay, so we had to figure out what times 4 gives us 6. Okay, so if we divide both sides by 4, we can figure that out. Here we go. So 6 divided by 4 is 1.5. Okay, 1.5, and that would be our velocity. Right, so 1.5 meters per second is the velocity, because that's the only thing that we can multiply by 4 to get 6. Okay, so we figured out the speed of each blob of putty immediately after they collide, because this whole thing is one blob and they're all traveling together. Okay, so whatever the speed of one is, the speed of the other is also that. Cool, so we're good with that. Next bit is calculating the change in momentum that each blob of putty experiences, right? So we want to figure out what's the change from before to after. Well, this is where it can get a little bit tricky, because before we were looking at these blobs independently, and then after we were looking at these blobs together. But notice how I've drawn my blobs, as kind of their own unique blob, right? So I just need to figure out what is the momentum of the blue blob, what is the momentum of the red blob, because I know what their momentum is together, right? But this is just the sum of their individual momentums. Now you can think about this in a couple of different ways. We know what the total is. We know that each blob has the same mass and they're each traveling at the same velocity, right? So they should have the same momentum, and whatever that is has to add up to 6. Okay, so you're probably thinking, well, then that would mean that they're each 3, right? Because if this one has 3 kilogram meters per second of momentum, and this one has 3 kilogram meters per second of momentum, you put those together, you get 6. Okay, and that's exactly what we can do, right? So one would have to be 3 kilogram meters per second. The other would also have to be 3 kilogram meters per second. Now, again, I only made that jump because I know that each of these have the same mass, they're going the same speed, and the sum of their momentums has to be 6, right? The other way you could look at it is just calculate their momentums independently, okay? So we know that momentum is equal to mass times velocity, right? So if I wanted to figure out the momentum of the blue ball after the collision, I would take its mass multiplied by its velocity, right? 2 times 1.5. Okay. Well, 2 times 1.5 is equal to 3. Right? And the same thing's going to apply to our red ball. 2 times 1.5 is equal to 3. Right? Because again, I know that their speeds, I know their individual masses, I know my momentum equation. Okay? So if we want to calculate the change in momentum, remember your change in momentum is another word for impulse, right? Change in momentum. Figure out, well, our blue ball started at 6 and it ended up at 3. Okay, so its change in momentum from 6 to 3, that's a change of -3. Okay, that's a change of -3. My red ball, on the other hand, went from 0 to 3. So that's a change in the positive direction. So that would be a positive 3 kilogram meters per second. Okay. And again, notice that our impulses are equal but opposite to each other. So whatever ball A gave to ball B also gave to ball A, but in the opposite direction. Okay. So that's just how you can solve some of these sticking problems. Again, trying to think about it as you've got 2 individual pieces that come into one, right? But you can still identify those pieces independent of one another. They are stuck together. Okay, so they're going to travel together, but they're still their own pieces, right? But the biggest thing that you can probably do for yourself is just always recall that the total momentum before the system is equal to the total momentum after the system, right? And as soon as you can identify some of those missing pieces, you can kind of work your way backwards to figure out both their speeds and their changes in momentum, right? So hopefully this helps on that second question. As always, if you have any questions, please reach out to your teacher. And thanks for watching. Bye.